So I wanted to give you a few more examples of arithmetic sequences. So you could have something like 17, 22, 27, 32, and so on. And you see the common difference, hopefully. So if you don't see the common difference, remember you can take any two terms and subtract them, 32 minus 27, and you get 5. So the difference here, the common difference is 5. And you can check that, 5 plus 17, and then 22 plus 5, and then 27 plus 5, and so on and so forth. The first term would be a sub 1. That's where the sequence is starting. So that makes a difference what number you're starting on, right? Okay. So let's have another sequence. -3, 1, 5, 9, 13. And they don't always give you a lot of them, but you should have at least 3 so you can establish a pattern. Sometimes they'll tell you it's an arithmetic sequence. Okay, so you take any two terms, doesn't matter which two consecutive terms, subtract them. 9 minus 5 is 4. So the common difference is 4. And then you can check, is -3 plus 4, does that equal the next term? Does 1 plus 4 equal the next term? Does 5 plus 4 equal the next term? You know, and so on and so forth. 9 plus 4 equals 13. Okay, so there's an example. I want to do one more example. So let's say you have 7, 1, -5, -11, and so on like that. Well, if I take any two consecutive terms, so -5, you have to take the later one and subtract the previous one, -1 equals -6. That is the common difference then. That is D. Okay, so what I'm getting the negative common difference here. So you could say, oh, you're subtracting. Okay, that's fine. So 7 plus a -6, does that equal 1? 1 plus a -6, does that equal -5? And then -5 plus a -6, does that equal -11? And see, the common difference is a -6, but the pattern is holding. Okay, so I just wanted to go over some examples. So a recursion formula, we've talked about those before, it's when your term is based on the previous term. So if you know the first term, like back here with our 17, and you know the common difference is 5, then you're adding 5 to get the next term. And then you would take that term, so a sub 2 in this case would be 17 plus 5. It'd be a sub 1 plus that common difference. Okay, so this is what we're talking about, a recursion formula. And then to find a sub 3, you'd have to take a sub 2 and add 5 to it. That's what we were doing when we were checking it. So the recursion formula looks like this. For an arithmetic sequence, it looks like this. A sub n plus 1 equals a sub n plus the difference, okay, that common difference that you're finding. That's how you find the next term. Okay, so hopefully it all makes sense to you. I'm probably talking too much. Okay, they have to give you some information because it makes a difference where you start, and so they usually will tell you the first term. So in this example, it says, write the first 6 terms of the arithmetic sequence in which a sub 1 equals 6, and then they give you the recursion formula. Let me rewrite the recursion formula. I don't like it when it goes to a different line like that. Okay, so you see you're taking the previous term and subtracting 2. So a sub 1 is 6. If I want to find a sub 2, then I take the previous term, a sub 2 minus 1, and subtract 2. But that's going to be a sub 1 minus 2, or 6 minus 2, which is 4. So a sub 2 is 4. Okay, to find a sub 3, then I have to take a sub 3 minus 1 minus 2. And so that's going to be a sub 2 minus 2. Well, what was a sub 2? We just figured it out. Or, I just wrote the wrong number. 4 minus 2, which is 2. So a sub 3 is 2. Well, you can keep writing these out, but what are you doing every time? You're subtracting 2, right? Or you're adding a negative 2. So it's 6, 4, 2. The next one would be 0. Then the next one would be negative 2. And then the sixth term would be negative 4. So it said find the first the first 6 terms, and there they are. 6, 4, 2, 0, negative 2, negative 4. Those are the first 6 terms. Okay?